So, hello everyone, I'm Kevin Paul, and today I'm going to do a demonstration about how to build a simple schematic in LTSpice and how to connect it, how to place the various components, and how to run the various analysis which we performed. And this will be good as a good exercise to help those who want to kickstart their journey with LTSpice and want to learn how to build circuits faster, as well as how to perform various functions and how we will see the waveforms, how we will see the results, a way how to make the results look cleaner and neater so that you can use it in your presentations and in your reports, etc. So let us begin. So for this demonstration, I've considered a simple series RLC circuit. So I'll begin by placing a resistor. So I place a resistor over here. I do Control R to orient it in the proper orientation as I want it. And I do a left click. Now another resistor comes up which I don't want to place, so I will click escape. Then I want to place an inductor, so I will press L, and it is in the another orientation vertically. So I will again press Control R, build it in this orientation. Then I will click the left click to place the inductor. Now I don't want to place another inductor, so I will press escape. Now I want to place a capacitor, so I press C. Capacitor comes up. This orientation is fine with me, so I will click it here and then I'll click escape. Now I also want to place a voltage source. So I will click V, and here a voltage source has come. So I will place my voltage source over here and I'll click escape. Now I want to connect the circuit with wires. So to do that, I will press the key W. So I press the key W, this you will see this as symbol has come. Now I will connect the wires over here. I connect the resistor to the inductor. I connect the inductor to the capacitor. Then I connect the capacitor back again to the voltage source, and thus I complete my circuit. It becomes a closed circuit. Now there's something missing in the circuit which is known as the ground. So I press G, and it comes up as the ground. And let me go slowly, and then I press the ground here and I place it. So now again I click W, and then I will connect my circuit over here again. So I press the space bar. When I press the space bar, the circuit will fit the screen. Okay, and if I want to zoom in, I have to roll my mouse up, or to zoom out, I have to roll it in the opposite direction. Okay, so this is how I can zoom in and zoom out, etc. Now I don't want to place any more wires, so I will click escape. Now I want to set the value of a resistor. Let me set the value of resistor. Say, what I do is I right click my resistor, and then I will set the value, let us say 20 ohm resistor. The inductor L, I'll right click it and let me say the inductance, let me put it as 0.01 Henry. The capacitance, let me put it to be, let us say 1 microfarad, so 1 new. So there I placed a resistor, inductor, and a capacitor. Now I have to give a voltage, right? So the voltage, I will right click it, and the DC value, let me set it as 5 volt. Okay, so I've set all these settings, and now I want to run my circuit. So what I will do is I will go to simulate. I will click run or pause, and it tells me what different analysis options which are available in LTSpice, the various options. The transient, AC analysis, DC sweep, DC transfer function, DC operating point, transient frequency response, etc. Many options are there. So I'll go with the DC operating point. Okay, that is the steady state operating point. So what happens is it treats capacitances as open circuits and inductances as short circuit. So I click OK, then I place it, and it tells me what is the operating point. So these are the various operating points, and it is not clear what it means. Okay, it is not clear what it means. So VN001, N002, etc. The currents of the capacitor, inductor, resistor is understandable. But what are these points N001, 002, 003? So if you see, this circuit has 3 nodes. Okay, it has 3 nodes. This is node 1, node 2, node 3. So dot OP, the operating point, was telling me what is the voltage at node 1, node 2, node 3. And since it is a DC operating point, the inductor acts as a short circuit, the capacitor acts as an open circuit. So the voltage over here is 5 volt, voltage over here will again be 5 volt, and over here will also be 5 volt, because no current will flow. And so the current over here is shown to be 0, very, very small magnitude. Okay, so now we have found the DC operating point. There's a way to put a label to the net. Let me say this is V out. Okay, so this is my output node. Okay, and let me say this is V in. I will right click it and I will give it term V in. So this is my V in, this is my V out. Okay, or let me make it, this is my input node in, sorry, and this is my output node out. Okay, so when I run the DC operating point again, it will show my V voltage at input is 5 volt, the voltage at output is 5 volt again. All right, and the voltage at this node 001 is again 5 volt. So now after this operating point response, let us go for another analysis known as the time domain analysis or the transient response. So I will click configure analysis, I will go to transient. I'll see the stop time. Let me run the response for like 1 millisecond. Let me start saving data at 0 seconds. And let me start the external DC supply voltage at 0 volt. Okay. So this, if you will notice, this has been disabled. So the operating point command is disabled, and this spice command dot trans 01 milli 0 startup is put into, and this will run the circuit when I click this run button. So now what I have told is that this voltage source will start at 0 and then it will rise to 5 volts. So let us see how the response looks. So if I click run, this is the response. This is the voltage at the input, how it is starting from 0 to 5, took some time to reach, and this how the output is responding, and this is the current through my inductor. So all these curves have come. Okay, and it looks like this. So this screen kind of doesn't look good. Like when you have made your schematic and you have run the results, and then you want to put it in your report and it looks like this black screen, it doesn't look good. So what I do is I will go to what is known as the settings, color preferences, and in the waveform, I will go to the background and I will make it white. This looks good for me. Okay, I have made it white and it is okay. So this is how the responses look. Another thing I'd like to point out is we can also change the width of the trace. So the trace width is kept 1. Okay, the traces will look very thin. And if the trace width, let us say, is made 3, this is how it looks. And if you make the trace width, let us say 5 or 4, this is how it looks. Okay, so a little bit of a proper balance you should get in the trace width, make it look good. This is how the input has changed. This is how the inductor current waveform looks like. This is how the output voltage looks like. So you can actually see the transient behavior of the system, and it is going from one operating point to another operating point, etc. So this is one response. What we can do now is we can run the simulation for more times. So instead of 1 millisecond, let us run it for 10 milliseconds. Yes, right. Yes. Then I run it, and you can see the how the response looks. So the output voltage is finally settling at 5 volt. And this is the inductor current. If you see this is the inductor current, this is settling at 0 milliamperes. So this is, you know, analogous to what we did for the operating point. So the operating point will, after the initial response of the system, where my system is finally settling. So my output is settling at, let us say, 5 volt, and my input current is settling at 0 milliampere. So this is seen over here in this plot. Okay, we can also, if we go to the tools and to the settings, we can also change these fonts. Let me do an example. We could change this font to, let us say, Times New Roman. So it looks better, more professional. It will look all right. And the settings, font point size, we can increase the size as well. It will look bigger. All right. So as per your needs, your preferences, you can change it. But here again, this has become distributed. So let us revert back. Is it possible? Okay, so this is remove the inductor current waveform altogether. Let me go to the settings. The font size back to Okay, so this is the response. So now here all the curves are in one point. If we don't want this, all right. So let me, what I say, delete this trace, delete the inductor current, input voltage also I'll delete. So I'll place my output voltage I've placed over here, and then I can add. I will add a trace. I can add plot pin above. So I've added a plot pin above, and this is a trace for my inductor current. So I have put the inductor current separately and the output voltage separately. I can also add in this trace. I click in it and I click the input voltage. Input voltage is shown over here, the output voltage is shown over here, and the current is shown over here. So they are shown separately. So this is another way in which we can plot the results so that it looks graphically, and we can put it in our presentations, in our reports, etc. So now I'll consider another case where we another type of analysis that which is known as the AC analysis. So what I'll do is I'll delete this transient output and this operating point, go to the simulation, and I'll configure the analysis which I want. So I will go to the AC analysis. I want to sweep to be a decade. Sweep the number decade is like from 1 hertz to 10 hertz, 10 hertz to 100 hertz, 100 hertz to 1000 hertz. So it's in multiples of 10. And how many points I want in decade? Let me take it as 10 points. Let me start the frequency, let us say at 10 hertz. For frequency, let me take it at 1 megahertz. So that is 1 e to power 6. Okay. So I will place this response over here, the spice command over here, and then I will simulate it. Okay. So it's saying that no AC stimulus is found. So for doing this dot AC stimulus, what I need to do is I need to make this voltage source. Let me go to advanced, and let me put the small signal AC analysis of this voltage source as 1. Okay, the AC amplitude is 1. Then it is enabled the AC. So that means now there's an AC source, small signal AC source in my circuit. All right. So now let me run it. And now you can see the waveforms, how the body plot looks. All right. The input voltage will not have a proper body plot because it is just a stimulus. Okay, so this is the output voltage body plot, and this is how the inductor current body plot. So what does the body plot tell? It is that the frequency at, let us say, at 100 hertz, how my output voltage varies, how the inductor current varies. At this frequency, at the resonant frequency, how you can see that the inductor current is maximum. Alright, and other frequencies, how the inductor current is also decaying. So all these functions we can see. Now let us try to, so what we have plotted is the output voltage and then the input voltage. Now let me say, for example, I'll place this point at this node. So this voltage over here is the sum of the inductor voltage and the output voltage. Because the voltage plotted over here is the voltage of the inductor plus the capacitor. Okay? But suppose I want the voltage from here to here. Okay, so that's what I will do. What I must do is, okay, let me delete this trace. So let me delete this trace. I want to take the voltage from this point, and I will left click and I will bring it back to this point, and then it will show the voltage. It will show the plots. So this is the body plot of that as well.